All right, everybody ready? This is just a really general review for the transformations test. Okay, first of all, there are 3 types of isometries that we learned about. What's an isometry? Claire? Okay, in general, we want to make sure we refer to them as having the first shape first, right? So the pre-image, right, is going to be congruent to the second image is the image shape. So it starts with the pre-image, moves the image through some sort of transformation. So isometries have those 2 shapes are congruent to each other. What would be the 3 types of isometries? Right, reflection, rotation, and translation. Reflection we would call a flip. Rotation would be a turn, and a translation would be a slide. I'm going to post this video, so if you miss something, you'll see it later. Okay? What's a transformation that's not an isometry? Give me an example of one that we learned, Jenna. Dilation. And it's not an isometry because it changes size. It gets either bigger or smaller. Now, the 2 that you want to make sure you recognize the rule for are translation and dilation. A translation rule is going to look like this. XY becomes, and then what happens to the X? Nope, not for translation. For translation, we're going to do what to the X? Like if I want to move it to the left, what would I do? Claire? Exactly. This is either going to be X plus something or X minus something. If I'm moving to the left, I would do a minus. So this would be a left 2 because it's X minus 2. So when you see adding or subtracting to the X and the Y, you know it's a translation because it's just sliding. The X moves it left or right, the Y moves it up or down. So for this one, X minus 2, that would be to the left 2. Y plus 3 would move it how? Up 3. Good. That's just an example, right? There's lots of different translations that we could write. But you should be able to recognize the rule that looks like this. You should look at it right away and say, oh, that's a translation. Or if you are doing a translation, you should be able to write the rule from, whatever's drawn on a graph. Okay. The other one that you should recognize the rule for is a dilation. And what happens to the X and Y in a dilation? What happens to the X and Y? What do we do to it? Evan? Multiply, right. So this is going to be whatever the scale factor is multiplied by the X and the Y. This is a enlargement with a scale factor of 3. 3x, 3y. Everything gets 3 times farther away from the origin. If we have bless you. Your sneeze got on the video. Okay, 1/4 x and 1/4 y. What's this? What is this going to do? Yeah. Yep. It's going to reduce the shape. It's going to be a reduction. And the scale factor will be 1/4. Okay, so you should be able to recognize whenever you see a dilation rule, you should recognize, oh, this is going to be an enlargement. 5x, 5y, 3x, 3y, 2x, 2y, whatever. And this is a reduction, some sort of a fraction. You should also be able to obviously recognize a translation rule. Reflection and rotation, I don't need you to memorize, the rule for rotating around the 90 degrees, and you don't have to memorize those rules. You might not recognize those when you just see it, the rule. You might not go, oh yeah, that's a rotation, blah, blah, blah. That's okay. In all cases, though, you should be able to take a point or a series of points and do some rule to it. So if I give you the rule, like that, and I say use the point 3, -5, and do this rule to it, you should be able to handle that. You might not know exactly what it's doing, but you should be able to do it. So you're going to plug in x is 3 and y is -5 over here. So if x, this symbol in front, means change the sign of x. So if it was positive, it's going to become negative. If we're going to keep y the same, it was negative, it's still going to stay negative. Okay? Remember that this little symbol in front means change the sign. So I could do this same rule to this point. And what would it become? Same rule. If we change the sign of x, what's going to happen to -4? Becomes 4. We keep y the same. Okay, so that doesn't mean it becomes negative, that little sign. Okay, it means it changes its sign. All right, so you should be able to take any rule, even more complicated rules like this. Actually, kind of wrote that wrong. If we start with xy and it becomes this, right? Then if I start with the point 3, -2, what this rule says is take whatever was in the y position and put it first. So here's the y position, -2. I'm going to put it first. Now take whatever's in the x position, put it second, and change its sign. So that one's a little bit more complicated. This is more important for the 21s in the room than the 22s. But make sure that you can do any of those. You might be asked, what does this do? Graph this. So if we start at -4, 1, and we end at +4, 1, what kind of a transformation is that? What did it do? It reflected over the x-axis. Oops. Over the y-axis. This is the y-axis, right? Y is high. Okay, yeah. Yeah, you won't have to find the missing side. You don't have to find the missing side. You will need to find the scale factor. Let's do one of those. Okay. So if I have a and then I ask you what's the scale factor. And if it started here, let's say A, B, C, and this is A prime, B prime, C prime. Which one is the original figure? ABC, right? And we said with calculating the dilation, you always want the original on the bottom and the new on the top. So in this case, the original, let's take the side of 4. it becomes a side of 6. So the scale factor is 6 over 4, or 3 over 2, or 1.5. With a scale factor of 1.5, would we expect this to get bigger or smaller? Bigger, and did it? Yes. Always check that with yourself, because if you accidentally flip this and make it 4 over 6 and you get 2/3, and you look and your scale factor is 2/3, you should expect to see something shrinking. And if you know it's clearly not shrinking, then you probably mixed up what goes on the top and what goes on the bottom. Does that make sense? All right. And sometimes it's not always left to right. Like on the homework, I did it left to right. But what if I made right? What if I made this A prime, and this B prime, and this C prime, and this one A, B, and C? Well, now which one's the original? The one on the right, right? So this one is shrinking. So original on the bottom again, you're going to do 6 on the bottom and 4 on the top. Then this will be 2/3, because it's going from this to this, so it's shrinking. Okay, so you just got to be careful that you're looking at where the primes are for that. Okay, so that is those are the general transformations. That's in general what you need to know. You might need to, on the coordinate plane, take a shape and do something to it. Remember 90 degrees, counterclockwise is actually the positive 90, right? If you wanted to go clockwise, it would be a negative 90, okay? And remember, you can use patty paper on the test, so if that's the way you do it, then don't worry, you can still do it that way. All right. 180 degrees, clockwise or counterclockwise? What's the difference? Claire? There is none. Right, there's no difference. It will always end up in the same spot. Reflection. Let's take a reflection. If I reflect this and I connect the pre-image point to the image point, this line of reflection is doing what to that segment? What's happening to that segment? Jenna? Yeah, it's bisecting. It's cutting that segment in half. Those 2 points should be the same distance from the reflection line. So not only is it a bisector, but it's a perpendicular bisector. It's actually cutting it at 90 degrees. 21s, you should be able to do a series of transformations. In other words, take one shape and do first a rotation and then a reflection and see where it ends up. Yeah. Yep. No. No. Skylar. You will need a compass, and I have mine that you can borrow, but you know they're not the best. But you will need a compass. I'm going to go over that in a second, too. The only other thing is with line symmetry and rotational symmetry. Okay, line symmetry is when a shape has, you know, a line that you could draw down, think of it as a folding line. If you folded it on that line, the two halves would look exactly the same. Okay? Rotational symmetry is like my toy that I brought in, right? If you have a shape that when you rotate it, it actually fits right back into itself. So if you think of this as like a puzzle piece, and there was a notch that this piece fit into like this, right? And you could fit the puzzle piece in. If you could pick up this star and rotate this point so that it rotates this way and becomes this point, that's one rotation. And then you could go click it 1, 2, 3, 4. This would be an order of 5, and the degree is always 360 divided by the order. So in this case, it was what, 72. Each time you turn this, it's a 72-degree rotation. So that's the degree of rotation. Okay. Lines of symmetry, you know, you got to just check. Some shapes have a lot more than one line of symmetry, like a rectangle. Can I go diagonally through a rectangle and make a line of symmetry? Nope. Nope, because you take a diagonal. If I cover this up and I reflect this, it's really going to look more like that, right? Kind of more like a kite. So it's really sometimes tempting, but that does not. That only has two lines of symmetry. Okay. Let's talk about the constructions. Right. The first construction that we learned was creating a congruent segment. So you would take your compass, right? Let's pretend this is a compass. This is the pencil part of the compass, right? And you would measure that distance. And then you would say, okay, I want to make that same thing over here off this point. See if I can actually move this. Oh, I kind of can. Okay, and then you would move this over, and you would mark this, put a dot, and connect. And that would be the same length of segment, right? We had problems where it was like, what if you wanted to have that segment plus this segment? So now I want a new segment to start, let's say, at point C, and I want it to be the length of AB plus DE. Well, you're just going to take this, and you're going to do that mark, put a dot there, right? Then you're going to take your compass and make it measure this one, and add that one right on top of that. And that's going to be your whole length. That's AB plus DE. That make sense? Okay. That's congruent segments. The other thing with segments, we found the perpendicular bisector. So if you want to get half of the size of a segment, you want it to be cut in half, you put your compass here, the point here, and you make it wider than halfway, okay? And then you're going to make an arc there. Take your tip of your compass and put it over here now, and do another arc this way. Clearly I'm not doing this perfectly, but you get the idea. Where those two arcs intersect at both points, you're going to connect them, and that becomes the perpendicular bisector. So you now have found the halfway point. So if you're supposed to be drawing a segment that's half the length of XY, you're just going to measure from here to here, And repeat that over there. Right? So it kind of combines both of those constructions. What if you wanted 1/4 of xy? Well, you got to come back here and do the same thing to this half. Get the perpendicular bisector of that half. Now you have 1/4 of the original segment. Okay, so that's with segments. The angle construction, if you want to repeat that exact angle off of this point, remember we took our compass and we made an arc and a matching arc, and then we measured with our compass here. Right? We measured, pretend this is the compass again, right? You measure how wide this is. You line it up with these two intersection points. Then you take that and you put it over here and you mark where those would intersect. Remember, you need that original, that red arc here, because that tells you how far away from the vertex to measure this intersection. Okay, and then that just creates the congruent angle. Be the same size. Okay, and we're going to start the same way to get an angle bisector. Start with the red arc anywhere. These two intersection points are going to be where we stick our compass and make a circle all the way around. You could go all the way around, or you could just go part of the way around. But you're going to have a circle with that point as the center, and then the same exact size circle with the other point as the center. And then where those two circles intersect is the angle bisector. In class, we did it not as full circles, but rather as an arc, and then connect it. All right. Anybody have a question, or did I miss something you think I should have talked about? Okay, say goodbye.